Hello everyone, and welcome to Lesson 5.2, Inequalities on the Number Line. We are picking up from where we left off in section 5.1 about how to graph inequalities and review what inequalities were. So today what we're going to look at are what are solutions to inequalities. And we spoke about this a little bit in 5.1, but solutions for inequalities mean that you have more than one number. Right, so for example, if I had the inequality x is greater than 5, any number greater than 5 is technically a solution. So 6 would be a solution, 7, 8, 9, 10, all the way up to 100, a million, infinity. It doesn't matter. Any number greater than 5 could be an answer, right? So in this example, on the page here, you see that I just gave you 3 random numbers that were bigger than 5. That was 7, 10, and 23. So all of 3 of those are possible answers. And we have to be okay with, in inequalities, that we have multiple answers, and we have to understand that. Now, also in math, when we have inequalities and we're trying to express a lot of answers, there are a lot of different ways that we can express answers as solutions. There is one particular way that is covered in 5.2, and that is called set notation. Set notation uses the braces, and those are the squiggly lines that you see below in green. Those are actually called braces. And the braces contain or hold inside of them the actual solution set. And a solution set is just any set of solutions that you choose to work or that may solve the problem. So for example, if I gave you 3 random numbers, which were 7, 10, and 23, if I were going to write those answers in set notation, I would write them as brace 7, 10, 23, close my brace. If I had more numbers that I needed to include, I would write those in there. If I had fewer, I would write those in there. But I would always do it the same way, and I would get in a habit of ordering those from smallest to largest, with the smallest number coming first and the largest number coming at the end. That's just a good typical order to express your answers. So again, you are going to see something called set notation, and set notation uses braces, and the braces contain what is called the solution set. And that terminology is going to be very important because you're going to see that come up over and over and over in problems, and it's important to know what a solution set is and how to express things in set notation. Now, one of the other things, as I scroll up just a little bit here, is that if you happen to run across an inequality where you actually have to solve for something, I have very good news for you. Since we spent most of Chapter 4 talking about solving equations, solving one-step equations, two-step equations, when we get to inequalities, especially with one-step addition or subtraction problems, we don't have to do anything different other than what we've already done in Chapter 4. So if I were to give you this problem, which you see in pink, x plus 4 is less than 10. If I wanted to solve that, all I would have to do is just do the opposite operation. I would subtract 4 from both sides, cross the 4's out, and that would leave me with x is less than 6. So solving inequalities, should you get those in this section, all you have to do is what you already know how to do from Chapter 4. Nothing special, no real crazy rules yet. There is a special rule yet to come, but for this section, all you have to do is take the opposite on both sides, and you're good to get your answer. All right, so let's get into our examples here. We have 4 examples of how to, different types of problems that we'll see in 5.2. The first example says, write a valid solution set for A is greater than 12. So what we know is that our solution set is going to come inside of braces. And just as a rule of thumb, let's just put 3 numbers in there. if you get to create a solution set on your own, you just have to choose any three numbers that you want that are greater than 12. The easiest three are the next three in line. So 13 is bigger than 12, 14 is bigger than 12, and 15 is bigger than 12. So if I needed to write a valid solution set for A is greater than 12, I just picked any three numbers that were bigger than 12, put those in braces, and now I'm done. All right, moving on to number 2. It says a number greater than or equal to 11. So this goes back to how to write equations and write math statements from English sentences. Just as we've done before, we just take different parts and replace them with our math. So a number, we've already talked about this. Anytime we see a number, we're just going to assign that a variable. Then we have greater than or equal to. That's self-explanatory. Greater than or equal to is going to be our sign. Greater than or equal to. And then 11 is just the number 11. And that pretty much gives us our answer. X is greater than or equal to 11. All right, moving on to number 3. We have 3 is less than or equal to x plus 5. So again, when we're doing this, we don't need to do anything special. I see plus 5 in the problem, so I do the opposite, which is minus 5 from both sides. Cross out the 5s. 3 minus 5 is negative 2. And we say 2 is less than or equal to x. If you wanted to switch that around, or maybe in the event you got a multiple choice problem that has all the variables on the left hand side, remember we flip it over like we're flipping over a pancake. So x and negative 2 trade sides, and the arrow still needs to be pointing at the negative 2, and so we do that to give us x is greater than negative 2. Our last example in this section is write a valid solution set for x is less than or equal to negative 2. Again, this is just like number 1. If I need to do a solution set, that has to go in braces. I'm just going to pick 3 random numbers. But one of the biggest things that we can do here is realize that it gave us x is less than or equal to. So in this problem, I can pick any numbers that are less than negative 2. So like I could say negative 10, I could say negative 5, but I could also choose the number that's equal to negative 2, which is negative 2 itself. So the difference between less than, greater than, less than, equal to, greater than, equal to, are that we can include the actual number that is being compared. And so just kind of watch out for that and figure out what the best course of action for you is, and whether you can include the actual number that's being compared in the solution set or not. All right, guys, this has been a quick review and covering of section 5.2. Hopefully this has helped you out and will help you solve these problems in this section. But just remember, if you have any questions or you need anything, please reach out to me and let me know.